Okay, I'm in the basement of Mason Hall where the chillers are located, or absorber. This is a Danfoss FC-102 with a factory bypass. No bells and whistles. This is straight from the factory with no unnecessary options. It has the minimum required controls to function as a variable speed drive with a bypass feature. I put these in 2009 as a case study because there was discussion back then also, why does the university spec out so many additional extras that may increase lead time and cost. And that discussion goes on today, and I want to just clarify a couple things that maybe you might lose with going with this option. So I put these in, like I said, 11 years ago. I just had one fail the other day that I'm working on. I'm working on this one right here. And you open this up. Okay, that's what it looks like on the inside. So one problem that I have is this failed the other day, and I have a bypass feature and it's on a cooling tower. So I had a problem with the drive, which is on the left. This is from right here over to the left. That's totally just the drive. From here to the right is bypass and the auxiliary cabinet. So I had this fail. Normally with what we install today, I would have been able to put this into bypass and then service the drive separately with it being de-energized. This version you cannot do that with because the drive has the disconnect for the drive built into the drive. So there's actually a disconnect switch right on the drive, and I can turn that off and it does de-energize the drive, but these fuses are still in the circuit here and I'm still energized right here. So in order to service this drive, I have to turn the whole complete unit off, which is undesirable. So what we currently put in is the same model, current model FC-102, and this drive has no disconnect built into it, or it has no fuses in it. Everything is in this cabinet below, and I have all of my controls, which you would refer to as bells and whistles. I've got 4 pilot lights. I've got power. If my safety circuit's tripped, this will light. I have an indicator when it's running in drive mode, and I have an indicator when it's running in bypass mode. I have a handoff auto, which can switch between a DDC start signal and I can start it locally in hand. I have a drive bypass switch that I can select, do I want to run variable speed or do I want to run across the line? And then I have a local remote switch that allows me to switch from DDC speed signal, or I can switch it to local and select my own speed. So if this drive were to fail, I could put this into bypass, turn the drive disconnect switch off, the motor or load would operate in bypass, but this complete portion would be de-energized, and I can service it, I can work on it while this is running in bypass. I can't necessarily do that with this or this. I pretty much have to turn the whole thing off so I can work on it. When I do that, your load is off, and that's the whole reason we have a bypass, is to run the load while you service the drive. The other thing, I don't have a control transformer into this factory option here, and the control transformer gives me 120 volt power, so I can run auxiliary loads or equipment like an EP or you know, a damper control or something, or a relay, what have you. I don't have that option here, so I'd have to provide my own power source and enclosure for that. You know, I don't have the option to be able to switch, you know, separate the two DDC signals. Like if I would want DDC to control the start-stop because maybe it's on a schedule, but I want local speed control because maybe a sensor has failed somewhere and it's not giving me the right speed, so I could put it in local and I could let DDC turn it on and off. I can't do that with this. All I have is a drive off bypass switch and a hand on or auto on. So that limits, that's kind of a nice feature to have that we do have on this. That's referred to as a bell and whistle. And the other thing too is if you look at the way that this is configured, okay, I have a bypass cabinet separate from the drive. If my drive were to fail, I don't necessarily have to put a Danfoss drive back in its place. I could get a low bid, it could be a Toshiba, it could be an ABB or whatever. I would take this off, I would put whatever manufacturer I have at my disposal and install that, and it would tie in real nice. All of my conduit comes into the cabinet, so I don't have to worry about repiping or pulling wire. With this setup here, you're limited. So in 10 years from now, when this unit fails, if Danfoss changes the shape or size of their next model or next generation drive, I would have a really hard time interfacing this with a different manufacturer unless they keep the same footprint. There's, you know, it kind of bolts together and it's pretty proprietary. So I'm kind of stuck here. So if this were to fail in 10 years and they change the footprint of the drive, I end up having to replace the whole thing here, which is undesirable. Now I'm going to take you over here and show you one other example. This is an older generation Danfoss. This is a VLT 6000. You notice the drive portion is on the left, the bypass cabinet is on the right. Well, I did have a failure a few years back on this one, and instead of replacing the whole thing, all I had to do was replace the drive. And I opted for a Danfoss current model FC-102. It fit in there nice, but I didn't have to. I could have put a Toshiba here if it would have been cheaper. I could have put an ABB here. I could have put an Allen Bradley, a Square D, a Cutler Hammer, whatever. I could, and by keeping this bypass portion, salvaging, because there's nothing wrong with, these are all hard parts in here, contactors, relays, disconnects, fuses, and I don't have to throw this out every time my drive fails. So keeping the bypass portion through several generations of drives is desirable in my opinion. And with our current setup, like I showed you over here, I can do that. I could pretty much this setup here with the drive and the separate cabinet just has a lot of desirable features. It does cost a little bit more money, and it does add a little bit of lead time, but I think in the long run, the benefits outweigh the negatives. So, and as far as lead time is concerned, this is what everybody likes to refer to as an off-the-shelf item. So it's not really off-the-shelf. If I were to order this drive and it has no additional features, this is just a standard bare minimum drive. If I were to order this, more than likely they would have to put it into manufacturing, and it would be a couple weeks before I would get it. So because these have a shelf life of 6 months because of the capacitors, they don't just make them and they sit around. Now I do have an option to buy off the shelf from SSI or Galco, and for this particular drive they would probably charge me about $800 to $1,000 more to have it the next day, because they keep it on the shelf and I guess they go through